Hi everyone, this is Jia Lei. I'm a PhD candidate at Syracuse University. I'm going to present the performance of in-duct bipolar ionization devices on pollutant removal and potential byproduct formation in indoor environments. Indoor quality is very important for people's health, and we are all exposed to different air pollutants such as VOCs and particles. And during the pandemic, we also have risk to be exposed to coronavirus. To address the IQ issues, a lot of air cleaning technologies can be developed, and they can be roughly divided into portable units and in-duct units. And the technology we are interested in is called in-duct needle-point bipolar ionization technology. This technology is pretty popular these days, especially during the pandemic, because many manufacturers declare that their product can enhance particle removal and also kill viruses on the particles. And also because of the low voltage it used, it can minimize the release of ozone and other byproducts. But there's still very limited research in this technology. And as I know, there are some debates on the performance of this technology. And based on our review of the commercial products, we roughly divided these products into three types. The first type contains only single pair of ionization pores, and the second type contains multiple pairs, and the third one contains more, and usually in different bars. And so in this technology, in this research, we focused on these two configurations. The first one is the ionizing bar. The ionizer we tested, it contains 4 bars, and they are mounted on a MERV 8 filter, and it has 34 pairs of positive and negative poles. And another ionizer is a portable unit. It has 6 pairs of poles. And this one is both of these ionizers are installed in a blower system. And this blower system has a blower fan at the inlet side, and it can control the airflow rate of the blower system. And the filter is installed at the outlet of the blower system. And we just place this blower system inside the chamber and to simulate the recirculate the air of the duct system. And during test, we maintain the airflow rate of the duct of the blower system as 505 cubic meter per hour. And in order to simulate a realistic indoor scenario, we build up an office space inside our full-scale chamber, and the office consists of the carpet floor and painted gypsum wall boards as wall panels and the ceiling panels. And we also placed a table and a heated mannequin with soiled t-shirt inside the chamber, and the 2 mixing fans. And also we have a HVAC duct system connected to the chamber, and this can provide purified outdoor air to the office space. And during the test, we actually have 3 different airflow rate settings. And first one is we only have the air infiltration, and the air tightening is pretty well. And the second one is we call the low airflow rate settings. This one just to reach the minimal value of ASHRAE standard, and the high airflow rate setting is almost the double of the low airflow rate. And because we have HEPA filter and carbon filter in the duct system, so in order to simulate the real scenario indoor space, we need to inject particles and VOCs. Both concentration for VOCs, we just inject the formaldehyde and taurine using dyno calibrator, and both pollutants are maintained at a typical indoor concentration level. And we actually also have a mannequin with soiled t-shirt, because we want to know the reaction between the skin oil and with whatever compounds this pollutant system generated. And we also measured the concentration of particles, ozone, VOCs, CO2, and negative ions at the exhaust of the room. And during test, we have two different test procedures. The first one is called decay test. So we inject particles at the beginning, then after to reach a certain concentration, then we stop injection, and it followed by a natural decay period. And after a certain period of time, we turn on the fan, and without ionizer, then we can know the removal by the filter. Then after another period of time, then we turn on the ionizer, then we can know the removal by ionizer plus filter. And another procedure called constant source test, and which means we continuously inject particles and VOCs to the chamber and until it reaches a steady state. Then we turn on the blower fan, and until it reach another steady state, then we can know the removal by the filter. And after that, we turn on the ionizer, then we can know the removal by the ionizer plus the filter. So based on these test procedures, and we can calculate the clean air delivery rate, CADR, and also the single pass removal efficiency of the technology. Here comes some results. The particle removal performance. This slide shows the result from decay test, and we can the figure shows the concentration change over time for different tests. And for the first one, it's just the natural decay. For the second one, after the natural decay, we turn on the blower, and we can calculate the efficiency of the filter itself. For the third one, third and fourth one, after the natural decay period, we turn on the ionizer plus the filter. So then we can know the efficiency of ionizer plus the filter. And for the last one, test 5, after the natural decay period, we only turn on the ionizer and we remove the filter, which means we can calculate the efficiency of ionizer alone. So this table shows a number of different tests, and we can know that the efficiency of the filter, mermaid filter, is pretty low. It's only 1.7% of removal efficiency. And after we use the ionizer, it increased to 7.7 to 9.1%, which is a considerable increase compared to the filter efficiency. And we can also know that if we only use ionizer without filter, actually the efficiency is very limited. So then the results from the constant source test. And so from the data we calculated, we can know that the efficiency of the filter is around 1.0 to 1.6%, which is close to the result from the decay test. And after we use ionizer, the efficiency increased to 7.2 to 10.4%. We also consistent with the earlier result, and it has a considerable increase compared to the low efficiency of the filter. We can also calculate the individual efficiency of the ionizer itself by comparing the concentration of a steady state, of this steady state and this steady state. So then the result is around 4.9 to 13.6%. And this figure shows the particle size distribution during the test. And we also calculate the single pass removal efficiency for different sizes. And we know that for MERV8 filter, it can remove larger particles more efficiently, which is very obvious. But for ionizers alone, it actually removes smaller particles more readily. But when they are integrated with the filter, actually it will move more greater particles. So therefore, it is preferred to use ionizers and filters together in order to maximize its performance. We also measure the negative ion concentration because some earlier research says that if the ion concentration is too high, it may be harmful for people's health. And so actually our results show that most ions were removed by the filter. The number is actually very close to the background level. If we remove the filter, then the indoor ion concentration will increase a lot. This negative means negative ion. We can just focus on the number itself. So we also measure ozone. So during the decay test, because we do not have any outdoor air, so we measure very slight increase of ozone concentration. But during the constant source test, which means under the realistic scenarios, we did not measure any ozone generation. And for VOC, it's the same. The variation of VOC concentration before and after using the ionizer were actually within the background fluctuation we measured using PTRMS, which means we did not detect any VOC removal or formation during the test. And then is the electric power. So compared to the typical power of portable air cleaners, these two ionizers are the number are very low, so below 1 watt. So we also compare the power per CADR. The number again is very much lower than the typical portable air cleaners. So which means it can provide moderate particle removal efficiency without significant byproduct generation and with very low energy use. So here comes some results. So I already introduced, and this project is sponsored by Syracuse University and Carrier Corporation. And this is my presentation. Thank you very much. And I'm open to take any questions.